Okay, so page 327, 328. It's giving an example that if there's 83 out of 240 based on 240 trials, if you take 240 and make it 1200, you can figure out what x would be. You just have to set it up just like this. Okay, so it's saying why are these ratios that could be equal to each other? Why this ratio equals this ratio? And so we're talking about the red, right? So they're still asking about red. If you're asking about red and red, they're equal because it is asking both ratios are the probability of getting red. Okay, we have to solve the proportion. So to solve the proportion, we rewrite it. All right, if I want to make them equal to each other, I typically like the multiply then divide. There's many ways to do this. Some people would just multiply up or divide down, but I'm going to do 1200 times 83 equals 99,600 divided by 2400. Equals, if we took these out, 996 divided by 24 equals 415. All right, 415. So we get 415 out of 240. That's why. Okay. 415 times is the probability of red in 1200 trials. Okay, 1200 trials. All right, write a proportion that could be used to predict the number of times blue will be drawn. Okay, well, they are going to give you 500 trials, so it's x over 500. But then we already know out of 240, blue was 79. So it's 79 out of 240. So I'm going to use my same method, which I call like the multiply divide. So multiply across 79, then divide. So 500 times 79 equals 39,500 divided by 240 equals. So it says it would be around 160, a round up, 165 blue. Which makes sense because blue is a lot more likely than, or a lot less likely than the red. All right, so then it asks you to solve on the back, 328. Conducts a poll about the election for mayor. The current mayor is running other candidates. The results are at the table. What is the experimental probability? So if they actually did this, how many people would be for? So I've got that reminder bell going off. They need to add them all first. So 5, 6, 7, 8, 9, 10, 3, 4. So it's out of 40. Experimental probability is asking for a fraction. So out of 40, 25 out of 40 are for, 12 out of 40 are against, and 3 out of 40 are undecided. So we have to use the data to solve a proportion for if this was expanded to 1,000. So x out of 1,000, right? Then we're going to use each different one. So I'm going to say for, against, undecided. Okay, each one of them gets to have their own x over 1,000. Okay, and then we use the probabilities that we have. For is 25 out of 40. Against is 12 over 40. Undecided is 3 over 40. And then we use our magic formula again. Multiply, divide. Multiply, divide. Multiply, divide. Okay, So undecided, 1,000 times 3, I already know that's 3,000, divided by 40 is 75. So x equals 75 out of 1,000. All right, 25,000 divided by 40. 625 out of 1,000 would be for this person. 12,000 divided by 40 equals 300. 300 over 1,000 would be against them. So it really seems like this person is going to be elected mayor based on these numbers, right? So there will be 625 for, 300 against, and 75 undecided out of 1,000 voters. Lonzo spins a spinner and gets a red outcome 12 times. So red equals 12. He predicts that if he repeats it 1,000 times, it will be 240. All right, he gets red 12 times. He predicts that if he repeats it, so we don't know how many times he actually spun it. Interesting. So there's 12 here. We don't know. This becomes the x instead of how many times he spun it. But he thinks it'll be 240 out of 1,000. So setting up the probability here becomes the hardest part. Now we can do multiply, divide. Same way we did 12,000 over 240. So 12,000, and I took out the zeros so it would be a little easier for me on the calculator. So equal 50. So he spun the spinner 50 times. Okay, easy as that. So now you have what you need for 327 and 328.